I'm going to share a little bit with you the newer things that we have. Some of the things actually are also new to Milos. Some of them he knows. Some of them actually we just activated an update this morning, so you now have CO2 sensing actually on every device. But this I thought was good to show. It was good to show to you how it keeps developing, right? That it's not something that you buy and then it's static and that's what you have. In the end, for us, the reason to do that is, I mean, of course, I would like to be able to pay my employees their wage at the end of the month. But you can do that in many different ways. The reason we're doing this is that we feel okay. We want to improve the real estate on these aspects, and they're very commonly known, I think, to everyone in the real estate. They're the same for everyone. But beneath that pain that we need to solve, there is, we believe, a problem. And that is that these are all static assets, right? So we design something, we then build it. Maybe we first even make a brief. That process takes years. And then we build something that's static from not only like a brick perspective, but also from a software data perspective. And it makes it very difficult to stick with what society requires from us over, let's say, 15 years at least, lifetime of what we've built, right? It makes it very difficult. If, however, we would be able to go through this, right? So get rid of the silo technology, bring in the IT revolution we all know from our private lives into real estate. We can go from what we call outdated at delivery. We can go to making these things tools that just keep evolving, and not just by the requests of the users or the owner, or in this case, middle cap, but of the collective, because you're all using the same software, right? Like we get updates on iOS having new features that none of us require, but somebody else did, and you can still have access to them even though you didn't ask. Now, how do we do this? We built 3 layers. So the first layer you see physically. The second layer is, well, we call it the bGrid cloud, but it's like a whole stack we call of software. And on top of that, you have the third-party applications, and some applications of our own and sometimes custom. It's the same structure as a smartphone or a laptop has, right? Because it provides a lot of flexibility on the top, and you have this layer is identical for all buildings we do. And then, of course, buildings can still be prototypes, right? They can be different every time again, but all the software is completely identical. Now, this allows us to update all the sites, right? If we create a new feature, there is no implementation effort for us. It's just a software that we deploy, and it's 100% identical for this building, a hospital building in the Netherlands, or the MOL HQ in Budapest. Doesn't make any difference. So an example of one of these new features that we have now is related to this problem. We are also involved in the operational phase, right? And what we found is that very often people have discomfort in a room, they file an issue, a ticket, there is no response the next day, at best, in 2 months. Somebody logs in, says, hey, I don't see any error reports, so they have to, file a new ticket and again. And maybe after a couple of years, like 2 years, somebody opens up the ceiling and sees that somebody completely forgot to connect the cooling system. This is not a joke. This is reality. Now, so we make software that goes through this saying, okay, we're going to stop not checking our work, right? We want everything checked during construction. So what we do is we have software that tests every single control loop on every single aspect of the control loop during construction already, but you can do it anytime thereafter. Test it individually, so not all at the same time, because that doesn't tell you if maybe someone misconnected the set point of this room with the reception, such that if you want this warmer, the reception is getting warmer and you're not having any response here. And again, that is not a joke, but reality. So we do this, and this is very technical. So you see here a graph. This is in the middle of the night that we run the software, one room individually. We give a set point change. We say, hey, it needs to get 2 degrees warmer. And maybe you'd think it doesn't get 2 degrees warmer. Well, trust me, in real estate, this is already very good, right? So if we would say this is not good, nothing would be good almost. This is unfortunately also very common. We call them flatliners. You know, it's like where you measure your heart rate when you're dead. That's what you get. That's what you see here, for example, yellow, all the yellow spaces. This is a property at Schiphol Airport. They've just completely renewed the building automation system, implemented our tech as well. It's an existing building, existing tenant. And the green ones are the only four areas here that are good. The blue ones are what we call, moderate, means like we see some response. So somebody connected something correctly, but you don't see the right capacity, right? We see very good responses on this, actually, of everyone in the industry. Of course, the owners like us, the consultants like us. We also see that the contractors like us because it allows them to prove quicker to the owner that they actually get what you pay for, which unfortunately is the sale pitch here. But we also see that the contractors like it because it provides them a tool to their subcontractors to say, hey, this part's not working right, go fix it, right? So it's fast because somebody's finished, we run it in the night, the next morning you get the results. Another update we ran was it's called Be Adaptive. Actually the same building as you can see. Now the trick, what we do here, and never mind looking at it too carefully now because it will rewind every time, is that what probably all of us know, in real estate, the majority of the time during the day, spaces are vacant, right? A building like this, any building, typically has opening hours from let's say 7 in the morning to 10 in the evening, where we can already see in our data, we can forecast this space, nobody gets here before 8:30, and when it gets available after 4 p.m., nobody's going to come back, right? Yet the night mode runs from 10 to 7, right? But it could have run from 4:30 to 8:30 in the morning. We do this at home, right? Because we all want to save gas and not fund Putin too much. So what we've made is software that automatically forecasts, okay, how is this space going to be used today? When can we put it in night mode? And then it does the same in the morning to stretch it and reduce the day mode. What you see, this is the clock. I've just started it at showing it at 5:30 in the afternoon, and all the green leaves is when, okay, this room has now gone into night mode. So instead of having a fixed program identical for the whole building, we just use AI to forecast, okay, when can we put it in night mode, when we have to take it out of night mode again, such that there's no discomfort. And this actually, we're very happy with this because what we see is that we get a reduction of more than 30% of the day mode of the HVAC system. And in this property, it saves more than 20% on the HVAC energy, which is the larger part of your energy bill of a property. And we save energy. We don't go with a screwdriver in the building. We save it when no one is there anyway. So, it's all win, right? And it's just a software update. And again, it's identical for any property that we do. Then the next step is, and this is also new, is that we can then tell you how much HVAC energy is being utilized in which area of the building. Now, this is very relevant for ESG reporting because you can, of course, then, sum that up to, okay, so how many kilowatt hours per square meter have I used in a certain time frame of the year, which is in the EU is now a requirement from next year that you be able to do it, but more and more corporations are adhering to that also outside the EU. But it's also interesting because you can do it on a tenant level. So it means that, for example, at this building, Middlecap can go to a tenant and say, okay, we can provide you an ESG report for just your space where we have incorporated how you actually use the space and what you have, say, requested from the HVAC system, which provides an incentive for them also to actually, use it intelligibly, right? Normally, everything just gets divided by square meters, right? So if you have another tenant 1 floor up and he just uses twice as much AC as you do, you both pay the same per square meter. The other new thing, which I just mentioned, is estimated CO2. Okay, we do sell them, right? It's good business, but air quality is very important, and air quality sensors are very expensive. And we've seen in properties that very often they're in some places, but not in all the places that they're interested. right? And that's a loss, right? So we found a way with AI and all the different things we measure in our system to actually see, okay, how much CO2 is there in the air in this room without actually measuring it. When we started doing this, we thought, okay, if we can just say the air quality is good, moderate or poor, for most people that's enough, right? Most people don't, normal people that work in a building don't know what CO2 ppm means. But I'll show this to you. It actually is a lot more accurate than we thought. So if you, oh, now I have to, 1 second, duplicate the screen. Here we go. So this is live. This is the same view, but then in light mode that Milos was showing. So if we take, normally you have, this is the normal CO2, right? So you have CO2 sensors here, and there are 2 in this event space. And now just this morning, we switched on this one, is the eCO2. So that means that in every, we use it in every tenant confined space, we can estimate in real time the CO2 of that space. You can see it's just switched on this morning. And this is, in that sense, real tag. So what the system does, it starts learning, right? So it automatically calibrates. So actually today, these estimates are not yet very accurate, and then tomorrow they're better, and then like in 1 or 2 weeks it has stabilized, and you have accurate estimates that are so good that now actually in the Netherlands we're starting to use this also to control the amount of ventilation in a room, that you can do that dynamically without having to install a hardware sensor.
Can I just ask, if you're not counting the number of people, and you haven't got a CO2 sensor, how are you?
Yeah, so it's a good, interesting question. So we actually, so we do estimate the amount of people in the space, but that's more or less, well, not entirely, but it's partly the same logic. So what we do, so we see the amount of movement in a space, we see the amount of energy that's in the air, it's the enthalpies, the combination of temperature and humidity, and we know the type of space. So we know what type of activity is typical for this space. That we know, and this is the kind of metadata also that Midas was talking about. By knowing the type of space allows us to have different algorithms for different types of space. We use that as well for people estimates. So for example, people estimate, maybe easier to relate to, open desk areas. We use a different algorithm for a meeting room because the pattern of movement and the amount of energy in the air in a meeting room yet is different for 6 people than for 6 people sitting behind the desk. This is more or less the same logic, but then different. So you train, we say AI, it's really machine learning. I have never in my life seen a lot of AI. It's really machine learning, so it's a mathematical model with a lot of parameters that you then train on a reference model. So we used point grab cameras that can integrate in our system. They were installed in some of our client facilities, and we used that data set to then train the model. Yeah. And it's like Michael says, the people counting, we've had that now for a little over a year. That works really well. Because nobody's interested in in real time, okay, are there like 4 or 5 people in this space? Not even on the desk level, so that nobody's interested in that, right? It's more, where is it busy, where is it crowded? How do we typically use this meeting room? For that is perfect. And maybe in that line, so this is another feature we've released recently. This is the kiosk screen. It's meant for vertical narrowcasting. I've highlighted here 3 floors of this building. And what you see is, so this is a workplace area, for example. We know how many desks there are there, and we currently measure that roughly all of them are occupied. That's where it's red. Here, the occupancy is below, the utilization is below 20%. People, we have clients that use this at every elevator and staircase because, the idea of people looking at a phone to see, I've got a desk at the 3rd floor in the right corner just by the window, that's still free. Nobody does that, right? So what people do, you go to the building, you come in, and you look, you have 2 seconds, you want to have the information of where to go, right? Where is it crowded, if you like the buzz, or where is it quiet, if you need to focus. That's what they use this for. And that's where we use the people counting for as well. So. All right. So this is a new element. We have these new things all the time. So this was released start of last year, the people counting. We use actually LEDs in the node. You can choose to switch that on, that we give visual feedback if the air quality deteriorates, all kinds of updates. And in this way, we're really, and this makes me really enthusiastic, that we're really delivering on this idea of, having something evolving. So not, people counting has been switched on here for some time, but it's not in our contract with Middlecap, Like you have many features in Office 365 that are for sure not in any contract with Microsoft, right? But that's how things progress. And what we see a lot, actually, is that how there are these topics where you could have discussions over. For example, in an organization, hey, do we need more meeting rooms, right? If you have that discussion on a management level, it always is a lot of people with an opinion, right? What we now do is we provide data. You can still have the discussion. It's just going to be a hell of a lot shorter, right? Because the opinion is no longer relevant, right? It's only about what you think about of the data. These are some of our references. Middlecap is one of them. We hope to be doing a second project with them here in London, but you can see there are many different companies that do repetitive projects with us, which for us is, of course, very nice. I did want to tell you what we actually do in detail, very briefly. So what we actually do, so this is the latest version of our hardware. It does more or less the same as that. It just takes 230 volts or mains power. So we sense everything in the space. So you can see the people counting is now actually in new contracts. That is something that we do. The estimated CO2, we have the full light management. A new element is also that we provide the full control of the comfort in the room, including controlling the actuators. So there's no longer any building automation on a floor level. And we provide the power to the actuators. We integrate with blinds, everything. This is actually also very powerful. Miles explained it briefly. We have so you could say like an indoor GPS system that accurately positions where you are in the building, which floor, which room, etc., to make sure that you cannot access, for example, the controls of the room next door, but also to make sure that if you want to provide, for example, here in Office App, a meeting room, that if you're on ground floor, you're not proposed with a meeting room at the 5th floor. You're looking, it's called location-based services, right? You can look at where somebody is. Our system can also track assets. So in hospitals, for example, we track hospital assets dynamically. This then sits in this structure that I explained before: hardware, software, and then third-party applications. And what actually is also now, for the first time since I started this 8 years ago, is that we get contractors telling us, hey, if we implement bGrid, we've got so many things that we no longer need, including the integrations between like light management and climate management, that you can install our system, what we call Smart Building Ready, but don't have any investment that you need to do. And that really helps us, to go further. And this is one I like personally a lot. So hey, we trust one, right? And then all others must bring data. This is also how we run our company, right? If we have ideas, we just want to test it quickly, get data back, get feedback from our clients. This is why we're so close with Milos and all the other clients to, actually understand what people are using, looking at utilization reports of our own software, et cetera, to have the data to make the right decisions. And that, in the end, helps us in this transition to digitalize real estate a little bit. And so far, we hope to be at the core of that. Yeah. Any questions at this stage? I see Naf looking at, okay, you really have to wind down, but yeah, one done, yeah.
You mentioned that you're obviously constantly updating your software.
Yeah.
You can get the most out of the sensors. Is there not a point where your existing sensors in the building don't allow you, because that is your static evidence, your hardware.
Yeah.
That the software, the data you're trying to establish from that, you can't get the refined data because that's the limitation is the hardware, essentially.
In theory, yeah, but no, not to date. No. So so for example, if you look at like our first generation projects, this is not this. Here there is a slightly different infrared temperature sensor than we used before, for example. Sometimes some devices are sensors like microelectronics are end of life by the supplier, so we just it's not like they communicate that, it's just like we're stopping this, good luck. And then you have to go look for something else. To be honest, the accuracy of the hardware is far beyond what the real estate industry actually uses. So that's not anywhere close an issue. But yes, it does cost us money to make everything backwards compatible. But yeah, if you go for something and you believe in it, then yeah, that should not be a surprise, right? So, yeah.
Where is it also produced? Is it produced in one location, one factory, or do you have a number of locations doing this product?
So actually, Priva, some of them are also here. They're a majority shareholder now of our company. So we use their supply chain to produce our hardware, the latest version, which is, to be honest, a blessing, because in the whole microelectronics shortage crisis of the past 2 years, we would not have been able to ship anything without someone like Priva that is on a much bigger scale. Because I mean, they're not just building automation, so they're world market leader in indoor farming automation, and so they procure all the components, and they have a supplier with really high-end factories in China where they assemble everything. It's get QA'd and then shipped. Yeah.
So this, well, especially in our country at the moment, embodied carbon's a huge.
Yeah, we noticed. Yeah.
So, procuring on the other side of the world and shipping all this equipment to the UK or other locations.
Yeah, so we wrote a white paper on that. So if you tap on us, we'll be happy to share. The white paper is based on scientific research that we found through ChatGPT, so it's a very useful tool for that. And because the equipment is very light and not very big, so shipment is not anywhere close on significance. We compared it to traditional systems. And you'd be maybe not, or maybe are. I was surprised to learn that there is a big gap. So our system is like, I think it was 40 or 50% lower in total on embodied carbon. But the biggest gap is actually that all the newer thermostats have a screen, and that's just terrible in terms of embodied carbon. Yeah. No matter what version. Sorry, last one. Then we move on. Yeah.
So you told us great picture of the highly integrated system. This connects to lots of different things. What happens when a system falls over?
So the question is, what happens if a system falls out? So, very relevant question, to be honest, right? So that is, and let's say if let's talk about maximum foreseeable loss from a functional perspective. So what really will never happen is that like all of the components in the different layers of the technology all fail at the same time. That's technically impossible, and also from a probability perspective. But of course, we could have like, let's say this node could fail. If that happens, the light goes on automatically. And of course, it will not switch off, and you will not have any sensor data. Now, in almost every space in every project, well, not so, it's 80% of the spaces, we have more than one device in one climate control loop. And then what the system automatically does, okay, it will then just, so typically for temperature, it will average between the 2 or 4 or whatever, then it will just, that will not be included anymore, but the climate control will keep working. Now, if we would lose all the devices in an area, typically that happens because the gateway loses power. That does happen sometimes. Because someone did something in the maintenance, then we would lose that entire area, and also the communication to the BMS is then interrupted. So yeah, the lights will go on, but they will not go off, and climate control no longer works. I think what's relevant to do understand here is that those kind of scenarios are not unique to our system. They apply to any this kind of technology, including all the traditional technology. There is, however, one big difference is we do real-time monitoring of all the components of all our systems, right? So the moment there is a significant issue, our support system get notified of that, right? Now, we do sometimes get the question, do you do that 24/7? We say, well, if you want it, yes, I'll make a quotation, and then that ends there, because in this kind of properties, nobody wants to pay for 24/7 support. But like Milo said, we think we're really on top of it, actually. So most of the times there is an issue, we either have flagged it, because sometimes somebody else screwed something up and we can't fix it. If we can fix it, we typically fix it before our clients notice. We'd have a service level agreement where we specify all the different levels, We report on that fully automated, so you can see in real time where we are relevant to our SLA, and we push quarterly reports, both about how your property is performing in terms of utilization, comfort, etc., but also in terms of the uptime of our system. Yeah. To be honest, I think we're quite more on top of all of that than the reference in the industry. Yeah. We have to be honest, because if we're not, yeah, I mean, we're the new kid on the block, right? So if something goes wrong, we're the first one to be scrutinized. So, yeah. Sorry. Yeah. Okay. Well. Yeah. Yeah. He was first. Yeah. Please.
How do you deal with conflicting set points that are very close to each other? So say you had a climate zone that was here, that was, I don't know, 50,
Yeah.
like somebody over there decides that
Yeah.
they wanted a 24.
Good question. So when we started, we did a lot of edge projects for edge edge technologies. They were really into that kind of thing, being able to, in an open space, have different comfort. Maybe at some point in the industry, we will be technically capable of doing that. We find that today having a control loop work properly, even if it's just for one space, can already be a challenge in the industry. So let's first try and fix that. Second, the climate systems that are capable of doing that, like active ceilings, they're so slow that they are far slower than what people would expect it to be. So, that's already a problem. So what we see actually in all the edge projects, where they sell it and then we still operate it, the tenants don't want to have any of this, right? They just want to have one set point per area, and in an open space, as a user, you cannot change the temperature set point. Same applies to lighting. They just want to have equal plane lighting, They don't want to have facade lights different than more internal. It just looks awkward. So it's just the same. We just do daylight harvesting for everything. So no, we don't do those kind of separations. We do get the question, what happens if, through your phone, one colleague says at a +2, then the other goes at a -2? Yeah, then I say, you might advise your colleagues to talk to each other. We can't fix that need. Yeah. Sorry, Peter.
I just want to take back to something you were talking about earlier on with regards to the dependence on the gateway to be able to distribute all the various sensory information. And you mentioned that should you have a failure of a gateway, that the lights would go on, the HVAC would go off.
Well, it won't go off.
But it goes out of control.
So
It goes on a static course, yeah.
Okay. So obviously from a landlord perspective, that potentially could cause issue if we don't have visibility and control of those parameters on the floor at any given time.
Correct.
So how would you overcome that? What systems have you got in place to sort of mitigate against that type of failure?
Well, first of all, we monitor it real time. So if it happens, we see it. We can reboot elements, assuming it's like a software failure, or sometimes if there has been a power outage, things can go sideways. We can even power cycle the devices remotely. We can fix a lot with that. Typically, if the gateway goes offline for a sustained period, it is a power issue in that area, and that we cannot fix, obviously. And so of course you can talk about theory, but in reality, what we experience, it's most of the time it's part of a bigger issue in that area. Say someone has done maintenance or a change, and they've unplugged something or cut a wire or made shortcuts that we call in English, short circuit, and tripped something, yeah, then that happens. And then, yeah, you do lose visibility, but rest assured that is not different from building automation, right? If you lose that kind of power or the communication infrastructure to your building automation components, offices are not built in a redundant way for that. We mean it's possible, but they're not built that way. Yeah. So you mean our infrastructure would allow for redundant gateways? That would not be an issue at all. It's just, yeah, you have to pay for it. Yeah. But redundant gateways would be a way to solve it. That's relatively easy. Yeah.
Data security, network security, Wi-Fi.
Yeah, no, of course. Yeah, no. So we do multiple Microsoft offices, Schiphol, Zurich Airport. Trust me, they're on top of that. So we get tested on that. They're called penetration testing. So you basically allow someone to hack your system. That has never happened. So we have never had, they're called major findings. If somebody gets in, it's never happened. The only part is the Bluetooth communication. I mean, it's not the only, as in that has happened there. All of the organizations that have been contracted to try and hack us didn't have people with skills to hack through Bluetooth. So I think that's part of the question, part of the answer. Then again, technically, if you'd hack the Bluetooth, the only thing you can do is you can listen to the sensor signals and you could control light and climate. There's no way to access our database or any of the higher architecture elements. So, yeah, it's cool. Good. Just because we have this, yeah, you can like in the app you can file the other questions. We've got Jody being anxious to take the stage.